All right, today you are going to be classifying triangles. And hold your applause till the end, please. I heard some excitement out there. I heard a yay. Now it's exciting. It's exciting. And in this section, you're going to be classifying triangles two different ways. The first way is by angles. All right, so when we classify by angles, we get four types of triangles. We got an acute triangle. And in an acute triangle, there are three acute angles. And let's just put maybe in parentheses right next to this classify by angles. Let's write angles sum. (180°). Just to review, the three angles in a triangle have to add up to 180 degrees. Okay? So, when you're classifying triangles by their angle measures, you've got an acute triangle. It's got three acute angles. Then you have what's called an equiangular triangle. In an equiangular triangle, equa is basically means equal. Okay? You've got three congruent angles. Equiangular. All the angles are the same. Then you've got an obtuse triangle. In an obtuse triangle, there is one obtuse angle. And the fourth type of triangle, when you're classifying by angles, is a right triangle. And in a right triangle, there is one right angle. And today, you're just going to be looking at pictures of triangles. You're going to look at the angle measures inside the triangle, and then you're going to classify it. It is. It's one of my favorite sections in the whole book. And turn the page. The second way you're going to classify triangles today is by side length. And when you're classifying by side length, the first type of triangle there is a equilateral. Equilateral means equal sides. Alright? Equal for equal, lateral for side. Side to side movement is lateral movement. So equal sides, three congruent sides. Picture would look something like, remember the tick marks we talked about earlier? In this case, you would see three tick marks. It means all the sides are the same. Isosceles triangle. In an isosceles triangle, two of the sides are the same. So there's a triangle with two congruent sides. And the third type, when you're classifying by sides, is called scalene. And that has no congruent sides. All the sides have different lengths. Any questions on any of those terms or definitions? Okay, do a couple examples. Page 239, look at example 5. And that first example, find the measures of the sides of isosceles triangle ABC. So we're going to find the measures of the sides of triangle ABC. And you've got tick marks on side AB or AC and CB, so they're congruent to each other. Side AC is 4x plus 1. Side CB is 5x minus 0.5. And side AB is 9x minus 1. So in order to find the measures of these three sides of this triangle, you need to know the value of x. And if two of the sides are congruent to each other, you can set those expressions equal to each other. So your 4x plus 1 is equal to your 5x minus 0.5. So if you subtract 4x from each side, then 1 would equal x minus 0.5, and you could add 0.5 to each side. So 1.5 would equal x. And then you just take your 1.5 back and substitute it. So side AC would be 4 times 1.5 plus 1. And that is 6 plus 1, which is 7. Alright, if these two sides are congruent, then side CB is also 7. And then side AB, you would take the 9 times 1.5 and subtract 1. So 9 times 1.5 minus 1. 9 times 1.5. That's 13.5 minus 1 is 12.5. So there's the three sides of your triangle. If you were given the same type of problem, find the measures of equilateral triangle FGH. And then you've got a triangle FGH. You got a 2y plus 5 for side FG. Side GH is 3y minus 3. And side FH is 5y minus 19. if the triangle is equilateral, what does that mean? Very good. All the sides are the same. So these would all get a tick mark if you wanted to. But what it means is that you can solve for y by just picking any two sides and making them equal to each other, okay? Whichever side you wanted to pick. I think I'm going to pick the 2y and the 3y. It's going to eliminate one step of the equation. So if you go your 2y plus 5 equals 3y minus 3. And subtract the 2y from each side. Your 5 would equal y minus 3, and then add 3. So your y equals 8. Now you can substitute. Right here you're going to go 2 times 8 plus 5, which is 16 plus 5? 21. That was tough, wasn't it? They're all 21, aren't they? 5 times 8. 5 times 8 minus 19. That's 40 minus 19. Yeah, that's 21 too. And 3 times 8 minus 3. That's 3 times 8 minus 3. That's 24 minus 3. Yeah, that's 21 as well. So the math is right. Any questions? All right.